Quantum mechanics, it is hands down one of the most successful theories in all of science. Seriously, its predictions about how the universe works on the tiniest scales are just mind-blowingly accurate. But here's the catch, the big problem. For almost 100 years, the smartest people on the planet have been arguing about what it all actually means. So yeah, let's dive into that.
So how can this be? How can a theory be so incredibly good at telling us what's going to happen, but at the same time be so completely baffling when we ask what reality is really like? That is the absolute heart of the puzzle we're looking at today. We have this amazing tool that just works, but it paints a picture of the world that seems to fly in the face of all common sense.
To try and bridge that gap, the gap between the math that works perfectly and the reality that seems so bizarre, physicists came up with these things called interpretations. You can think of them as stories or frameworks that try to explain what's really happening behind the quantum curtain. And we're going to start with the most famous one, the big one.
For decades, and I mean decades, the default answer to what does it all mean was the Copenhagen interpretation. This was the brainchild of the pioneers themselves, people like Niels Bohr and Werner Heisenberg. It pretty much became the standard story you were taught in physics class. It was the orthodox view for a very long time. Okay, so what does this standard story actually say? Let's break it down. First, it says the universe is fundamentally indeterministic. That means at its core, reality is all about probabilities, not concrete certainties. Second, there's the Born rule. This uses a thing called a wave function, which is basically a cloud of all the possible things a particle could be doing before we look at it. The rule just gives us the odds for each outcome. Third, and this is a really wild one, is the idea of collapse. The very moment you take a measurement, that whole cloud of possibilities just instantly collapses into one single definite reality. And finally, there's complementarity. Something can look like a wave, or it can look like a particle, but you can never ever see both at the same time. The kind of experiment you do forces its hand.
Let's just hang on this idea of collapse for a second, because it's probably the most mysterious and argued over part of the whole theory. The idea is, before you look, a particle is just a smear of possibilities. It could be here, it could be there, spinning up, spinning down, all at once. But the instant you measure it, bam! That whole smear of potential just snaps into one single actual reality. The what could be becomes what is.
And what's really fascinating here is that even the founders, the guys who came up with this standard story, didn't see eye to eye on a really crucial detail. Where does the weird quantum world stop and our normal everyday world begin? For Bohr, that line was drawn by the physical experiment itself. But for Heisenberg, this cut was, well, it was flexible. An observer could kind of move it around, deciding what to treat as quantum and what to treat as classical. So the big takeaway from Copenhagen is this. It forces us to accept a reality that's based on chance and depends on us, the observer, a world that kind of waits for us to look at it before it becomes real.
So, you would think this standard story is what all physicists believe, right? Case closed? Well, not so fast. A poll back in 2011 showed that, yeah, Copenhagen is the most popular single interpretation, but it's held by less than half of physicists. A majority, 58%, actually lean towards other ideas. The reigning champ is definitely not the undisputed king anymore.
Now, all this disagreement has led some thinkers to come at this from a completely different angle. It's a pretty radical idea that questions the very foundation of this entire debate.
This new argument asks a really jarring question. What if the problem isn't that we can't find the right interpretation? What if the problem is that we think we need one at all? What if quantum mechanics doesn't need to be explained?
And this is the core of it. The source material for this idea puts it so bluntly, saying that interpretations aren't just unnecessary, they're unwanted. They might even be misleading us, sending us down all these confusing rabbit holes. So if we just toss out the whole idea of needing an interpretation, what's left? Well, this new perspective suggests we need to completely rethink what reality is. Forget about separate little particles and fields. What if everything is just one single unified thing?
The author of our source text frames this whole idea with a deceptively simple question. You see, in physics, we're always talking about quantum fields, this fundamental stuff that makes up reality, where particles are just little vibrations. But the author asks, okay, what are these fields physically made of? If they're just abstract math, how can they be the real material world?
And this leads to this amazing, kind of beautiful way of seeing things. Imagine that reality is one single object, a giant 3D elastic fabric.
And this picture, all the things we call particles, electrons, photons, all of it, they aren't separate things at all. They're just tiny, complicated wrinkles and distortions in that one fabric. And us, humans, we're just incredibly complex, tangled up shapes made from the exact same fabric. And here is the punchline. The whole point is this. We don't need to find an interpretation for quantum mechanics because quantum mechanics is the interpretation. It's the mathematical tool that we, these complex wrinkles in the fabric of reality, came up with to make sense of the world. It's our way of dividing up a single, unified reality into neat little categories like particles and fields, distinctions that, in the grand scheme of things, might not even be real.
This whole perspective, it actually builds towards a very famous and often misunderstood phrase in the world of physics that suddenly starts to make a whole lot of sense.
Shut up and calculate. It always sounds a bit harsh, right? Dismissive. But if you look at it from this one fabric point of view, it makes perfect sense. If quantum mechanics is simply our human-made tool for understanding our limited perspective on a unified reality, well then using it to calculate and predict things is exactly what it's for. Maybe the search for some deeper meaning behind it is missing the point entirely.
And that leaves us with this huge final question to chew on. Are our scientific theories, especially something like quantum mechanics, a true map of what reality is actually like? Or are they just really, really good tools like a compass or a GPS that we've invented to help us get around in a world that, in its truest form, might be way beyond our ability to fully grasp? What do you think?